All right, subcourse TR 0655, edition A, or sorry, edition 4, railway rolling stock, draft gear and couplers, chapter 5. Railway cars are made up into trains. They are connected to the end of the rail jargon and coupled the device of the coupling, pulling, pushing, and uncoupling process of the draft gear. The couple of the draft gear is connected with the car underframe, seated with the car still pockets, and receive the reduce the shock of the pulling of the truss between the transmitting of them to the car body. The coupler is attached with the draft gear. The chapter discusses the first of the draft gear couple are in use in the United States. Second of those found in the rail equipment in the foreign countries. 5.2. The draft gear connects the coupler with the underframe of the cushioning shock being caused by the cars. You use the couple and train speed and suddenly change. A certain amount of the slack is purposely left in the coupler standing in the training so that it can be started at one car at a time. Cars are usually coupled this speed of about per hour. You can imagine that they would be heavily loaded with the freight car standing in siding while it was struck, and a couple of the of the cars moving in at 5 miles per hour with a solid connection between the coupler and the underframe. Something would have to give at the end of this run out of slack with the shock of the curves. The draft gear placed between the coupler and the underframe is designed to cushion such shocks. The two basic gear types of the draft gear used in the United States are friction and rubber. 5.3. Friction draft gears. All friction draft gears will have two major components contained within the housing. A unit of coil springs. A friction unit shows the three different kinds of draft gear. Figure 5.2 diagram showing the internal parts of the two types. Notice the figure 5.1 friction draft gears within the housing of the bearing of the coil spring. Friction units made up of plates, wedges. As the coil springs begin with the compress, they meet the resistance of the friction unit. The more the springs compress, for the harder the bearing against the friction plate. Thus, the more resistance compression procedures. Resistant action permits them to be started smoothly with the pressure release for the friction unit that prevents them spring from recoiling into the rapidly after the draft gear operates the same way the car is suddenly pushed rather than pulled. These are draft gears. 5.4 rubber draft gear is designed to fit the standard draft gear pocket in another frame. The rubber draft gear has been used in locomotive passenger cars for over 30 years and used the freight equipment to gradually becoming frequent. As present, rubber draft gears is found with the Army diesel electric locomotives and cars and the ambulance trains. On some of the troop and kitchen cars, the gear unit is shown in Figure 5.3. It includes the series of rubber plates that take the care of the shock of the couplings. 5.5 the coupler does these three things: connect one of the car with another and holds the connection. Then disconnects the two cars. Cars built with the country in this country before 1933 were equipped with what is known as the cutaway view, the decoupler. So almost all freight cars have had an E coupler. Some are bearing equipment, and recently F coupler. Passenger cars have an H coupler. Working principles of E, F, and H. However, the same next two paragraphs discuss the E-coupler and the maintenance, and after Wilson, Hook, and Lincoln, the couplers and foreign equipment as are described. Here shows the coupler and the draft gear spring kind. Other draft gear, follower plate yoke, rotating rod, follower plate, coupler, gear unit. 5.6 E-coupler. The complete E-coupler is shown in Figure 5.4 with the working parts of the diagram labeled in 5.5. The coupler is complete automatic with the locking coupling process. However, it must be manually unlocked before the cars can be uncoupled. It shows the coupler. The coupler may be unlocked either the top or the bottom, depending on how the rotary lock or lifter is actually parts are assembled. The coupler is designed so that the parts can be changed for either the top or the bottom operation. Either the operation performed safely from beside the cars, raising the uncoupler lever. This is connected with the rotary lock lifter. It shows the knuckle pin, the lock of the fulcrum, the body, the shoulder, the lock of the ledge on the lock, the ledge on the knuckle thrower, the trune on the ledge extending over the knuckle thrower, the rotary lock lifter, the lock seat toggle, and the projection on the lower wall of the coupler cavity, and the knuckle. The main working parts of the coupler follows the mount is meaning the section includes the horn, guard arm, shank, butt, and the head of the hose is the coupler operation. The knuckle is rotating hook, the hinge of the knuckle pin, the connection to the knuckle pin of the another coupler. The knuckle locks the drop in place. The knuckle locks and prevents the uncoupling the lifter when moved, and uncoupling the lift. The knuckle locks the freeze, and the knuckle throws. The knuckle throws the knuckle open, and the coupling of the lever continues to be raised. The toggle works with the lifter to lift and lock up onto the bottom operated couplers. 5.7 Coupler maintenance regulations cover all phases of all maintenance requirements of the coupler. However, most of the minor relations to the two most important requirements were discussed in the following paragraph. The two requirements deal with the proper coupler height and from the rail from the amount of the play in the knuckle. The coupler height of the coupler is too low over the card, does not couple properly when it is moving properly. Possible for them to uncouple. Coupler heights are measured from the top of the rail to the center face of the coupler knuckling using tools shown in Figure 5-6. Because of the difference in the weight pushing downward on the car, different measuring requirements exist on the empty loaded freight cars. On empty cars, knuckle centers must be raised at 34.5 inches. If it is at 32.5 inches on the less at the top of the rail, the coupler loaded with the car adjusted at 33.5 inches. When the knuckle center dropped in at 31.5 inches or less, the height of the coupler can be adjusted to adding shins beneath the truck springs between the center of the plates and the trucks of the body bolsters or both. Decoupler knock play. Excessive knuckle play can be cause distance from the knuckle to guard the arm to become great when the knuckle is locked in closed position. When this occurs, the coupler part of its mace. In Chapter 2, the full name of the wheel defect gauge was given, and part of its name was worn coupler limit. Shown in this gauge, the use the measure the knuckle play opening between the knuckle and the guard arm is too large. One of the three things that may cause the defect: the guard may be out of the contour entirely. The coupler may need to be replaced. The knuckle pin may be worn in either one or both of the parts should be replaced. The knuckle facing of the lock of the fulcrum may be worn. The knuckle should be replaced. The lock fulcrum built up by welding with two or more of these causes exist. At the same time, it would probably be safer and cheaper to replace the entire coupler. 5.8 Foreign couplers. Most of the rolling stock in North America is equipped with automatic couplers, draft gears, the absorbing, the pulling, the stress, and the impact shock. Most of the foreign countries do not have railways so equipped. The hook and link of the Wilson coupler are found in most overseas, except for in Korea, Japan, and China. And AR automatic couplers are used because military railway figures for measuring coupler height. Organization will use the equipment that they find in the theater or operations. You should familiarize with these two coupling devices. The hook and link, the three main parts of the hook and link coupler seen in Figure 5.8 for the screw coupling the draw hook on the two sides of the bolt. Referring assembly, Figure 5.9 shows the parts at the end of the railway car. The draw hook forms of the parts of the cars underframe. The screws coupling and the mounted at the base of the hook of the buffers are located on each side of the hook. This shows the height, measuring the height of the coupler and gauging of the coupler. This is the coupler detachments. Coupler toward the end of the car, the buffer has the housing attached to the spring-loaded section, extending with the housing. The coupling operation manually coupled the shackle, the screws, the coupler hooked for the hook on the other cars, the tighten of the screws until the slack is taken in the face of the two buffers on one of the cars should be pushed squarely against the face of the other car. When it starts the runs of the screws coupling and carries the pulling of the load, the buffers protect the cars, lading and absorbing the joint shocks and prevent the cars from running together. The function of the draft gear, the use of equipment to uncouple, they are unloosing the screws until they are even enough, slack enough to shackle off the hook. Besides the danger to the men working between the cars, this is the type of coupling equipment makes switching a slow, time-consuming operation. B. The Wilson, working with the same general principle, E-coupler use equipment with the Wilson coupler have been one marked difference. Transition difference was shown in Figure 5.10. Note that 6 makes it possible to couple the hook, link, and coupler, although the coupling automatically is like an E-coupler jolts and shocks are absorbed the side buffers and the draft gears. 5.9 Summary connection of the coupler of the car, underframe of the car, ears cushion the shock, and when the cars are coupled together with the train speed change suddenly with the friction draft gear. Found most of the U.S. rolling stock has a unit of coil spring, the friction unit contained with the housing, a spring compressed with the mush against the plates, wedges in the friction unit, setting of the resistance, permitting the cars to start smoothly, rubbering the draft of the gear of the locomotive passenger cars. Some of the freight cars offer the resistance from the serious rubber plates and absorb shock during coupling. This shows the coupler, the friction buffler, Wilson coupler, the buffer, spacer coupler, support, draft gear yoke, and transition devices. When the railroad must be moved from one place to another, it must be coupled with other trains, and they must be coupled and maintained until the reach the destination. The coupler must be unlocked and disconnected from the cars from other cars since 1933. Freight cars in the United States have been equipped with the E-coupler that performs the three functions. It automatically couples between them uncoupled manually for safe efficiency operation. Couple height must be properly set and the knuckle play must not be excessive. Couplers from foreign equipment of either the hook and link and the Wilson. Remaining the manual coupling, uncoupling hook and link, it has been linked in place over the hook of another coupler. The lever tightening of the connection until the slack is taken up. Buffers on either side of the coupler absorb the jolts, shocks, and preventing the cars from running together. A Wilson coupler is like an E-coupler that is couples automatically to using the buffer ends of the car's edge transition device. A hook and link, it makes it possible to connect the car, and it's installed with the car equipped with the hook and link coupler. Chapter 6, Brakes.